Okay. So let's talk about Agile and performance testing. And to start with, I'm going to share with you how I started with performance testing about 10 years ago. I was working for a software company who was developing software for colleges, kind of learning management system for like UBCs using the MSFU and many other colleges around the world. And at some point, as a system become bigger, our customers become bigger, our product management and marketing start to get questioned. What's your throughput? What's your performance numbers? And they decide, okay, we need to have numbers to publish them on website. So marketing was given budget to get the numbers. So because it was marketing-driven project, the first thing they did, they bought, of course, a lot of equipment, and then they built glass wall in a room, like really close to when you enter our building. And they said, okay, we're going to get these numbers. Numbers will be great. We publish them on the website. And when customers will come to visit to help our sales process, we're going to walk them to this room, show them all these nice blinking lights, and tell how great our performance is. So they did all that. This room was built. Hardware was installed. Lights were blinking. They asked, okay, now give us the numbers. It took us probably months, maybe more, month and a half, to be able to run first test. But when they got numbers were not good to publish them. There was really bad numbers. So this is kind of marketing-driven approach to performance testing. And this kind of got me thinking, and how do you do performance testing? What kind of skills you need to have? What kind of methodology you use? What do you measure? And it's a lot of interesting questions. And so also some challenges to it. It's one of the least understood areas of software development and testing, and probably one of the most complex ones. So this is why I thought that it's really good to put this presentation together. We are going to talk today about three things. What is performance testing? Because I think it really needs to be defined, and not everybody probably in the room was exposed to it, at least in all possible forms. How to do performance testing, and what's the difference when you do it in Agile? Does it help? Does it hurt? How people do it in waterfall? So as with any previous sessions, please interrupt me at any time. Questions, comments, stories. It all will be very interesting, okay? So, performance testing. I don't know if you can see here, but this is basically, on the right I have this screenshot of browser with website is not available, and picture of woman in high level of distress. So I'm not going to ask how many people experience that. But I want to ask you how many people were on that side of it, on the proactive. How many people actually plan for performance? Okay, so a number of hands goes out, yeah. So this kind of, we have a spectrum from be proactive and be reactive. Okay, we all are reactive, because if your application is down or site is down, yes, it's you getting call in the middle of night, and somebody needs to reboot the server, somebody needs to find a problem, somebody needs to really look through all these logs and trying to find out what's going on. So on a high level, if you start from proactive side, the first thing you do when you develop new system, you do sizing and capacity planning. You're trying to get as a part of your requirements how system is going to be used. How many users you're going to have? What kind of users are you going to have? Because there are different categories of users. I'm sure that every system has, let's say, e-commerce sites, what our company does, shoppers, the customer support people, and the administrators. They do different things. The different roles. So they're putting different type of load on the system. You need to understand that. You need to understand what kind of load you're going to have on the system. Like every retailer knows that most of the traffic, as well as most of revenue, comes during Christmas time. I work with other companies where the load also wasn't even throughout the year. Like in this learning management system companies that I mentioned before, we had semesters. At the end of semester, when all these papers are due and quizzes need to be tested, marked and so on, there's a lot of load during that time. But it's quiet during Christmas. So you need to understand all these characteristics of your system. And then in order to meet these demands, like normal load as well as a peak load, you need to plan for some hardware capacity for your networking, what kind of capacity your system should be, what kind of hardware you need to buy, how many data sensors you need to have, as well as during the same time you need to talk about reliability. What does it mean for your system to be down? How much revenue you are going to lose? Should you invest into fault tolerance, backup of data site? If something is down, is it okay to be down for 2 hours, or it's completely not acceptable? So it's all coming, all these things need to be determined during your planning session. It's part of requirements. And this is technical requirements, and they need to be known to the development team and the test team before people start implementing this. The next kind of stage is performance engineering. And performance engineering is something that, again, is done by both development and test team. So developers need to design their system to meet these requirements. Developers need to design their system so that it can be scaled. It can be put behind load balancer. It can have a hot backup database and things like that. Yeah? During test, you're saying how I'm going to design my tests. Performance tests are quite difficult to design. As with any test, you need to ask questions. What do I want to learn? And then design tests to answer these questions. And we're going to talk about different types of performance testing tests and different types of questions you need to ask. Also, during this performance engineering, this planning phase, you need to define what do you need from test equipment. And this is always a problem with performance testing, because you're testing under load. You need heavy boxes. And in most cases, practically impossible to recreate production environment. But during that time, you need to say, okay, how close I can come to production environment? What do I need how I'm going to emulate the pieces that I cannot have in my test environment? How well this emulation will do. So you really need to define your test requirements. You also need to select your tools. There are different tools to use for performance testing, and I'm not only talking about your scripting tools, but also your monitoring tools, your log analyzer tools, and a lot of other things that you will need. Then after it's all done, you need to do actually performance testing. Different type of tests we're going to talk more about, so you need to execute tests, understand results, and believe me, the most complex thing in performance testing is not writing tests, it's understanding what they mean. You're getting results, you see these graphs, and people don't understand why system behaves this way. Yeah? But after you analyze results, you actually need to fix problem and then retest. Because performance testing, and I even have this in one of my slides, it's like an onion. You're peeling onion, it's one layer after another. And you don't know what is the next layer. You don't know what next bottleneck is. And it's almost pointless to try to guess. You need to test, find, fix, test. So it's really a learning cycle. And in the end, you need to do monitoring and troubleshooting. Because system will go down. Doesn't matter what you do. Doesn't matter how much efforts you put in. Something will happen. The systems that we are developing now, they are too complex. There's many factors outside of our control. And when it goes down, then you need to have tools in place to understand why and be able to quickly resolve the problem. And you need to put these tools in place ahead of time. Because otherwise, it will be a very, very long night. And some of us had them. I was just sharing a story with some people here. Elastic Path, we do e-commerce platform, but we also ran some online stores ourselves. And we were running Vancouver Olympic online store. So if you really want to have this souvenir or jersey, this where you can go and buy them. And we did our performance testing. We have good performance testing practice, and we planned, design our test, and we design a conversion rate, which is ratio of people who are buying versus just browsing site. Usually we plan to have it around 2%. We tested for 4%, but we didn't anticipate that Canada is going to win gold medal. So everybody in Vancouver was very excited. I remember walking on the seawall and people even like jumping to water and swimming despite like what was this, February, yeah? And I came home and I got a call. Because after Canada won the gold medal, everybody got so excited. They really wanted to buy this jersey. They really wanted to go there. So everybody who went to site actually wanted to buy something. And we had about 25% or 20% conversion rate. And we haven't planned for that. So it was a long night. Okay. So different type of performance testing. There's load testing, there's capacity testing, focus testing, stress testing, and probably some other subcategories. So when we talk about performance testing, it's many different things. And you really need to cover all of them and at least have good understanding what you have covered, what you haven't. So to know where your risk is. So let's talk about in more details what it is. So load testing. It's kind of main, probably the most obvious one. And this most of the people would, when you talk about performance testing, what people first comes to your mind when you really want to put a lot of load on the system. Why? You want to learn your throughput. You want to understand, let's say, different ways to measure throughput, but usually it's measured in user transactions. So user clicks a button, something happens, page comes back. Let's say if you're talking about web application. So you need to understand what's your throughput under normal operation, how many users you can support. Yeah? Different ways, again, to measure it. Your test won't be able to emulate completely like user environments. So usually people talk about kind of sync time and number of active users you can support, and then you emulate them, and there's some formula to calculate how many real users it will be, because like your test is going to click without waiting, and user will need to process some information. But throughput allows you really to build your benchmark test, understand what's your system can support during normal mode of operations. Saturation test, it's something that when you're pushing system beyond like its capacity. So you kind of reach capacity, and then you're adding more load. And what should happen if system behaves correctly is that response time, system still operates, and response time becomes slower. But what may happen is that system goes down. So this is another kind of different test that you need to look at. Yeah? You also need to look at end user response time. It's proven that users lose interest if they wait too long to get some information back. In many businesses, lost user interest means lost money. So it's very important to measure it, so how system behaves from end user perspective. It's also very important to measure how system behaves from server perspective. Because you also need to know how your application server behaves, or how your database server behaves. What's response time depending on load do it, and what you can do about how you're going to scale it. So there's different types of type of questions you're asking during load testing. Capacity testing, again, we talked about this a little bit. So the peak active session per hour, transaction per hour, again, whatever makes sense, pick up your units, how you're going to measure them, and stick to them so you can compare it from release to release, from test to test. Stress testing. This is a kind of test that you want to break system. You really want to get it on its knees and see how it behaves. It may include different things, putting a lot of load, just disconnecting one server from the network, just unplug it and see what's happened. Yeah? Or what's happening if server is losing connection to database. even for a short time, how resilient your system is. Yeah. Try to do disaster recovery. Let's say your disk crashes in one database. How long is it going to take you to get system back? Unfortunately, we really learn how to do it in the wrong moment. In the wrong time of the day as well, yeah? Focus testing. Focus testing, and I'm going to talk more about this as well. It's very important, especially in Agile, because you may, all of this previous type of testing, we sort of talked about overall testing of the system. How do we test system under normal load, people doing different things. But systems are used in different ways by different customers. For example, we have, as I mentioned, e-commerce platform. And it's a generic platform. We also give our customers source code so they can customize the hell out of it. And different e-commerce sites behave differently. You may have a different size of catalogs. We have customers who have 50 items in their catalog, and we have customers who have millions of items in their catalog. It's a different test. You can have customers who have a single SKU, or like a variation of the product, or the customers who have several thousand SKUs. The same is different types of users. In some cases, you want to focus your test and test specific scenarios. For example, we had one customer recently who were using promotions a lot. So in our standard test, benchmark test, we had 3-4 promotions set up. These customers always have about 50 promotions active. So how a system behaves, how having 50 promotions affects throughput. So this kind of focus test. Yeah? The other focus test you can think about, if you develop a new functionality and you only want to test this particular functionality, then you may define focus performance test to really just focus on this particular feature. Yeah? They're usually different. These tests are different. It's short duration. It's usually putting heavy load, but in particular area. Yeah. So in order to do performance testing, what do we need? We mentioned that we need test environment. It's complex environment, and it's also maybe a very expensive environment. And your management may always be ready to approve it. But showing this picture of this woman who is kind of a little bit upset when site goes down and tries to convince them that it's really absolutely necessary. As some companies are doing performance testing on production environment. Very bad idea. Because some of these tests, they are destructive tests. It's something that we are trying to break system on purpose. You cannot do it on production. Yeah? Also, some of the production tests may be putting so much load on the system, so the system becomes not very responsible. I mean, you're losing money. It's against a dangerous exercise. It's not always possible to recreate your production environment. Try to emulate it as much as possible. Sometimes you may have different. It's also worth having multiple performance testing environment. You may have one for your performance test team just to play with, just to make sure that tests are running, because they need time to debug their tests and kind of to set up their tests. And that not necessarily should be high performance environment, but it should emulate what the like production environment as much as possible. You also may have some backup environment, and if you really cannot get your hands on appropriate hardware, that maybe what you can do if you have like warm backup for your production systems, this you may run some of tests on that environment. Yeah? But also try to understand what's the difference between this environment and your production environment. And difference may be huge, and you may not see them right away because they may be kind of outside of your application. For example, how many firewalls you have in that environment? Like we had a performance problem reported when it had nothing to do with the software, but had a lot to do with environment. So you, in a normal environment, everything is the same network. This is usually what people do. But in production environment, your web service and your application may be on completely different networks than your database because of IT security policy. So what's the network connection between your database server and application server? This may have huge effect on your performance, but you will never see it if you're not testing in environments that are close to production. So test environments, really, really important. Will take you time to build it. Will take you time to make it as close to production as possible. Work on it. You will also find out that your customers are having different environments than you. And I recently wrote a blog post why you need to do your own performance testing. Because whatever happening in customer environment is very different from your environment. And when you're talking to customers, try to understand that. Not only, as I mentioned, they may have different type of data which may change your performance characteristic, but also different environment, different hardware, and so on. Many customers will be open to do performance testing with you. And this is a good idea. Try to talk about them. One of my various company, because our customers were universities and were buying a lot of hardware, we actually had no problem working with hardware manufacturers like Sun or Dell or IBM or Oracle, because we were helping them to sell their products. So we actually did performance testing in their labs. And my performance engineers were extremely happy to go to Oracle lab and play with boxes as big as the imagination level was. Yeah, so it's a really good way to extend your testing capacity. Okay, so try to think out of the box how you can get your hands on more hardware, on more complex environments, and try to do it. Yeah, if you don't have, I don't know, access to hardware load balancer, which may cost still may cost a good one like 30, 50 grand. Use software load balance to emulate it. But don't forget that you do have load balancer. Yeah? The other thing you need to do performance testing are tools. There's many performance testing tools. Some of them cost a lot of money. Other of them are open source. And again, you need to decide how complex tools you need. You also licensing cost for this tool may depend on how many users simultaneously you want to emulate and so on. So look at your requirements because it may be quite expensive to do it. But after you select your tool, you need to develop scripts to do it. As well as you will end up creating a lot of your own tools that monitors, that parses your log and looks for some important things. And so it's kind of really a good performance team invests a lot of tools to make them kind of more productive. The interesting thing is that in order to do performance testing, you need working system. You cannot do performance testing on buggy software. And this is one of the reasons, one of the arguments I'm going to use later, why Agile is better than Waterfall. One of the problems that I had doing performance testing when using Waterfall process is that you're installing this system into a performance lab. You're spending like a lot of time to putting it, populating with data. It doesn't work. Performance testing was finding functional bugs, or these intermittent bugs that John mentioned that were not found before. So having a working system is prerequisite. Otherwise, you're doing performance testing 2 weeks before release, and guess what? It's too late. Because even if you find something, you won't be able to fix anything. And the other thing that I'm going to spend a little bit more time on this, you need skills. And this is really actually quite difficult skills to find. So let's talk about why you need to have those skills. This is an incomplete list of what the performance tester should know in details. You need to be expert in most of the performance problems that I saw were not actually application problem, what we call environment problem. And how good is just regular Java developers in configuring a network Cisco load balancer? That's the problem. So good performance testing people really need to understand a lot of different things. They need to understand DNS, routing, and load balancer, and what's the difference between them, and how do you switch from HTTP to HTTPS, and all of those things that may cause significant performance and instability problem. They also need to understand databases. The best one I had was actually DBA. He had DBA background. You need to understand how to monitor database. You need to understand what queries are the most expensive queries and why and during what operations. You need to understand database connection pools and different drivers and what driver leaks memory, what doesn't, and all of that. You also need to understand application server, different one, tuning of them. You need to understand development environment. You need to understand what does it mean so Java never leaks memory, yeah? Or why you are running out of memory. You should be able to do stack trace and read all of that. So development environment is very important to understand whatever you're using, like .NET or Java or whatever is your environment. And you need to understand what system is doing, what transactions are important, which are not. So for me, what's the most important thing in e-commerce? I want people to be able to buy something. Yeah? So if people are adding something to cart and cannot complete transaction, company lost money. If you cannot get to some particular category, it's less critical. If you cannot check on your last order, it's also less critical. It doesn't mean that it's not important, it should work. But you need to understand domain to also make this question. So these people are very difficult to find. The best way, try to kind of grow them in your organization and to just find out who has interest in that area, very exciting area. And if I encourage all of you to try to look at this, and because it's definitely a good career move for any testers. Unfortunately, there are probably some courses here and there, but you cannot go and get degree in or even diploma in performance testing. I wish, because we need more of people with that expertise. Other thing that was important to understand, and the same what I have on this slide and couple of next applies to automate testing as well. It's development. So we need to use all the best practices that we know. We need to apply them to performance scripting and to automated scripting. You can easily get into trouble. This is why most automation projects fail, is because you say, oh, it's just scripting. Here's a tool. OK, record what I do. Oh, I have first script. It's so easy. Well, when you have several hundreds of these scripts, it's all of a sudden becoming not that easy. And you need to maintain them, and need to be done properly. So all good techniques that we're using in development apply. This is why it's, when you're starting a performance automation project or QA automation project, I actually suggest that you get your most senior developer on it. Get them interested in this. Work them together with tester. Make them using object-oriented modular approach. It's architecture. So, so when you do it, you can look at your performance testing scenarios, different things you want to do, define kind of different session. Like in our case, for example, it will be add to cart session, or go through checkout, or do search and browse to categories. The different kind of scenarios that you want to test. Try to define them, what transactions involved, and do it in modular fashion. So this will allow you to do that. Then you can do long-running like stress test, but you can also create focus tests very quickly, just using these different blocks. Okay. Again, it's development. Use the most advanced development techniques when you're developing this. The other thing to mention about load test, just because of its nature, setup time may be quite long, because you need to have a lot of data. You really want to test in QA environment, you may have, I don't know, 3-5 customers in your database. Your customers are going to have thousands of them. Your customer, like when we're testing, we probably have, I don't know, a couple hundreds of orders in our database. Our customers are 3 years of operation, we'll have several millions of them. Completely different performance characteristic of the system. Yeah. So when you're setting up your performance testing, you need to take this into account and be able to populate this data. The other thing about performance test, it's quite takes time to do. And what's also frustrating is that you need to have multiple repetition even to learn what's going on. So your productivity will really greatly depends of how long does it take you to go through the single test. When we started to do it, when after this marketing budget gave us hardware, yeah, when we started to do it, we were lucky to have one successful test in a week. Because you're starting to populate data and it's process run for 5 hours, and then you run off temporary database space, and you start over again. Yeah? Or you're go through all this data population and deploy hardware, deploy your software, and by the way, because you have distributed environment, you deploy it in 5 places, yeah? You start your test, you have functional bug. Start over again. So one of the goals that I put to my performance team was be able to run tests in a day. And it took them time to achieve it, but in half year later, we were able to do it. At the end, we actually were able to do it in 2-3 hours. What do you do for this? You invest in automation. Automated deployment, automated data population, trying to do some, instead of populating database, having backup database pre-populated, and all of these things. Because you need, performance testing needs calendar time. I'm going to talk about later, is this why Agile is better? Because you can have access to working software early, you can have more cycles. You cannot finish it in one go. The only thing you can learn in one go is that it doesn't work. Okay, so I spent probably half of my time talking about what performance tests is without talking about how it's agile. So I have one slide to see to talk how it's working waterfall, and then we switch to agile. So you remember this one of my first slides, that the kind of those 4 phases: planning, engineering, kind of design of tests, then doing performance testing, and monitoring and troubleshooting. Yeah. So if you're using waterfall, it kind of fits quite well with other activities that you have in waterfall. So when you plan, you also plan for performance. When you're doing design, you also design how a system can go to perform. Develop, you write tests at the same time. Then you're doing testing, deploying, and maintenance. Okay, everything fine. But there are some problems with that. And here's the problem. Well, when you want to test, there may be no working system. It's too buggy to do it, because you really need to have clean system to do it. Systems that that actually can complete a single test for one user, yeah, before you test it for hundreds of users. The other thing that happened with waterfall, people are kind of continue changing all across the board. Because none of the feature was really completed. Bugs were delayed to fixing. So you really change. There's no piece of the system that you can test. So system is going to is changing all the time. Means your data population script needs to change all the time. Means your test scripts needs to be changed all the time. And this is what you're doing instead of testing. But the worst thing is that when you find performance problem, in most cases, it's actually an architectural problem. System was designed incorrectly. But you already coded it. How much you can change? So people trying to throw more hardware on it, or kind of doing caching, or working around, because there's no time, there's not even option to change system architecture. That's a really main cause. If you're learning too late that architecture that you proposed and implemented doesn't scale, well, too late. You may try to do it like in next releases, but even then it may be too late. You already invested too much into the system. Its cost of change is maybe tremendous. The other thing that I'm going to talk about is that when we talk about skills, you saw all the different areas you need to know. Yeah. So performance tester, you cannot test performance of the system the same as you cannot test quality into the system. So it's really a collaborative effort. You need to have developers available. And quite often on waterfall projects, if performance testing is done at the end, developers already work on something else. Or assigned to different project, or disappear if you were a contractor. Yeah? And you need to talk to them. Because really, you need to understand the system quite deep. Actually, developers help you, most cases, is required to understand what bottlenecks are and where performance problems are. Questions, guys? Comments? Anything? You mentioned something about this audience, they're not very active. What other words you used? Does it make sense what I'm telling so far? Yeah?
Experience problem.
Architecture
problem, because 1 month before releasing that, they actually rented big hardware because they could not afford buying it.
Mm-hmm.
They rented it for the last month to just test quickly the fixes and people sleeping at the office.
Yeah, no. We probably all experience that to some degree. Yeah. So let's talk about Agile. So this is kind of our iteration, and hopefully release happens sometime at the end. Yeah. Again, depending, there's no, all projects are different, but assuming that it's kind of your not first release, you may already have some test environment, some experience testing system. But anyway, what you're doing in iteration 0, so performance test should start from the very beginning. The same as your testing, the same as your environment. Are people familiar what iteration 0 is? It's in Agile terms, it's basically before you set up your environment, you set up your integrate continuous build, you set up your test environment, your developed environment. You're really preparing infrastructure for you to move forward with the project. So the same needs to be done with performance testing. And again, in this slide, I assume that it's kind of continuous effort. So you define performance requirement, you define what data you need to have, because even preparing data may take time. Some people take data from customers, but there's of course privacy issues for that. With that, so even if you get some data from customers, you probably need to run some script to delete the names or social insurance numbers or whatever else is there. Yeah. Then it probably would be a good idea to run your benchmark test. I'm assuming that you do have benchmark tests at that point. So you know like how your system performs, and you can measure, so okay, this is our starting point. In one of our previous release, my goal was to double performance. And we implemented a lot of different things. There was substantial refactoring done in the middle. And when we measured benchmark test, after some of development was done, we found out that we only have 30% of previous performance left. Yeah? So you need to know what performance was before you started to know where you are. Yeah? It's probably a good idea to repeat your benchmark test as you go through iteration. Again, if you invested a lot in your performance infrastructure, in your performance tools, in your performance environment, then it's not a big deal for you. And you have working software, you can do it. And this gives you a lot of information. Because when we learned that we only have 30% performance left after all our enhancements, we had actually still half a year before release. We have plenty of time to get it. And we ended up with, to get it up. And we ended up with performance 3 times faster than when we started the project. But you do need time for this. The other thing is that in each iteration, you're kind of working on different features. So depending on nature of the feature, but if you think that this feature changes performance characteristic of your system, or people can use it like this feature in a different way, like example of promotions that I was using before, define a focus test for it and execute it. And at the end, or if you can afford it, do it in the middle as well. You run all kind of standard load tests, your stress test, capacity testing, and different type of resilience testing to understand at the end what you're releasing. And this my, the question was asked question like, how much time you need before release. This is what you definitely need to do at the end, because this is what's going on. And even small change in your system may affect performance dramatically. So it's a good idea to, before you release, to know that, to feel confident with what you're doing, to run a full set of performance tests at the end. So I mentioned this before. You need a lot of calendar time. This is why you need to start early. And even if you, like, let's say you're working on the system and not entire system is ready, maybe you can define some focus tests and do performance tests on this one. Do it as early as possible. You will need multiple cycles. And you're going to scratch your heads looking at these results and thinking maybe there's some mistake or graph actually should be turned upside down, and maybe then it will make sense, yeah? And it's not always does. And you need to do it in collaboration. You really need a lot of different skills. You need performance analysts, performance tests, maybe different people who actually analyze performance and people who do script and execute tests, maybe a little bit different set of skills, depending how big your team is. You need to have senior developer and architect, somebody who really understands what system is doing at the time. Because performance, has people saying, okay, this is what we observed. And good performance tests saying, okay, not only measure that the system behaves this way, this what throughput you're getting on, or when it crashes, but also will tell you, okay, when the system starts to slow down, this is a stack dump, and this is where we're spending most of the time our threads are blocked on this call. And then developer goes to the code and see like, why? And trying to put it all together. You may need DBA, and you need network engineer. You need somebody who can measure throughput. We found our French customer recently complained about bad performance when the people who maintaining basically the customer service representative were using our admin application to go and work with orders and so on. We found out that because of how the network was set up, there was 4 megabit per second connection between these offices. Can you imagine? Like nowadays, in corporate world, like 4 megabit. And our application was designed at least admin interface saying, connection is good, we tested it in our environment, so we're sending a lot of data back and forth. So definitely a lot of problems with load balancer configuration, with DNS configuration, especially if you throw in SSL or some caching framework like Akamai and so on. Somebody needs to really, really understand it. So get your IT, if you don't have these people on your team, get your IT or operational people involved, and but try to get this expertise. So let's say we're inside iteration, so what are we doing? What we're practicing at WebCT is a lot of spikes. Everybody knows what spike is? For those who don't, when you have some question, you want to implement a system and you don't know how is this implementation possible or not. So in Agile world, we kind of define it as a learning exercise. So you basically say, okay, we usually time box them saying 3 days or 2 days. You go and code it. And at that time, your goal is not to produce working code. Your goal is to learn. So your output will be write up what I learned, good and bad thing. And developer goes in and basically just hacks ahead with trying to implement different scenarios. And at that time, you forget about code, you forget about this, you're just trying to prove that it's possible or learn how to do it. So you can do the same with performance. We're saying, okay, we're going to implement this feature and we don't know how it's going to affect performance. So let's try. So you work together with performance analyst, you time box it, developer develops something, you drop it in performance lab, run quick test. Oh, that's really is going to work. Or no, performance is dropping 50%. Go different decisions. So it's a good idea when you're doing this design decision, to make these design decisions that may affect performance, to do it, to run a performance spike. Then let's say you develop feature A in iteration, previous iteration, and then so you did test requirement, test development. Most likely, because performance testing is really a lot of things involved into setting up tests, and feature should be already stable. You cannot do it performance testing with the same iteration. But good idea to do it in the next one. And this is where kind of your focus tests come in. So you just want to test feature A. So you want to do it in the next iteration. Don't wait until the end. Because if you find some design problem with it that prevent you from scaling and achieving good performance, it's better to do it earlier. And so on. Not necessarily, not every feature requires performance testing, but many of them do. And it's much better to do it early. Yeah? And for each feature, you need to really plan to have multiple cycles. It's very rarely that you think that your first results gives you numbers that you want to ready to publish on website. It's not happening. Guys, questions on? Yeah.
Could you not, well, depending on what the feature is, of course, while they're developing it, have a task for the developers to look at performance and talk to, to think about it during the iteration as well?
Absolutely. There's a kind of different things. There's a different type of testing. There's some testing that developers are doing, like just using profilers and kind of tools like that. Absolutely, they need to do it. But this is kind of testing on one machine and just to get some feeling of how it behaves, or kind of some gut feeling. Absolutely. You may try to do it, and you definitely need to allocate time for performance activities during iteration. I think this is what your probably question is. And one of the best practices that I recommend in the next slide is to put performance tasks on the board. If you have planning board, put it there. Don't make them invisible. Yeah? Make sure that people have time to work on this. Yeah? It's maybe investigating performance problem that you discover that you coded in previous iteration, but still time is needed, so don't assume that it will be for free. Okay, best practices. We just talked about that. If there's functional bug that blocks performance testing, make sure it's fixed. Because again, you're delaying performance testing and you're starting this bad loop of delaying your problem, and you're finding to the end. So make it high priority. I would say because performance testing cycle is much longer than regular cycle, okay, you should be even higher priority than most of some of the functional bugs. It's a problem because your management most likely won't see them as bugs. They're not part of demos that you're doing. Your demo will work fine with most of them, yeah? But it's basically delaying problems for the later. The same. If you found performance problems slowed down, fix it. Or at least put somebody to investigate and work on this. Because you don't know that you fixed the problem until you retest it. So you need to go through another cycle in performance lab before you know the problem is fixed. Because the only thing you know is that you found bottleneck. The bottleneck behind it is invisible until you remove that one. And it takes time to find the next bottleneck, and then you know how severe it is. Maybe okay, you maybe live with it, maybe it's fine. Maybe you remove the bottleneck, you achieved your performance as required. But you don't know. So it's really, if you want to mitigate risk, don't delay fixing performance bugs, do it right away. As I said, your fix may not work. Be ready for this. And you cannot guess. Just don't try. There's too many factors. Like we were wrong so many times, and I had a room of really, really bright people who guessed strongly. It's just too many factors. It's the same kind of doing forecast or stock market forecast. That's the other thing. There's a tendency that you pre-optimize for performance. You assume there will be performance testing there, performance problems there. And when you have a hammer, everything looks like nails. So if you're a Java developer, what you're trying to optimize, your Java code. But problem may be in database, or in network, or in this third-party systems that you're integrating with. So do not pre-optimize. It's a kind of another part of don't try to guess. Of course, you need to, there's a good performance practices or not. Okay, don't make your session big, like be cautious of memory and all of that. Yeah, there's a great book called Release It. I recommend everybody to read it. It's about how to create production-ready software. But don't try to pre-optimize too much. You may be wasting your efforts and maybe actually going into the wrong direction. Also, what you think may be optimizing this, you may be caching to make sure that system works faster, may actually have negative effect depending on how much memory you have and how much memory is used by the rest of the application. Because if you exceed the amount of memory, system starts swapping memory. And this is slow. You may be better off actually trying to access database every time when you need this information. We talked a lot about this. Really need to understand production environment. And more you can learn, more you can teach your team, your entire team, tester, developers about that, the better. People need to understand that production environment is different than running entire system on your desktop or on this computer in the corner. We used to have a lot of bugs that came from the fact that database and applications were running on the same box. So we modify our QA environments. Now, like every QA environment is 2 boxes. And using virtual VMware, like it's not a problem to have a lot of kind of virtual boxes. But invest into this. You need to understand what it is. Then you can develop to make sure its system performs and stable in that environment. Logs. How many people are analyzing logs? Do you have tools to do it? Only one person for okay. So if I give you 5 gigabyte log, how long is it going to take you to find something useful there? 12 years. And there's another reason to look into logs. Because developers putting a lot of crap there. Something that is, doesn't help me to find the problem when I'm looking at this, okay? And this should be part of your testing. You should look into the log and say, what belongs here, what is useful, what's not. And when something crashes, I need to know what it is. And error messages that we have in logs, so it's sometimes it's quite funny, especially when you're trying to get something useful from them. Yeah, logs are important, and I remember from John's presentation 2 years ago, he has a lot of good tools to parse them and get something, analyze them, and get information from them. You need to have them. You need to share them with your customers or with your operational team. It's something that you give them. So when they call you and saying system crash, and you say, okay, what do I do in the middle of the night? You actually say, instead of this, they can give you, okay, system crash, this is logs. And this is how we analyze it. This is our areas that we need to look at. Sometimes performance is good enough. So don't try to put too much effort in it if it already performs well. So you need to understand, as part of requirement, define what is good enough, what is acceptable. Because load is going to vary depending on the time of the day, success of your business, and so on. So you need to have this kind of boundary when system is considered good enough. You need to discuss it with your business users, and don't invest too much time to make it better, because it's good enough. This is also very useful to know. Talking about don't panic. Yeah. Sometimes you can throw more hardware on it. You may have a problem convincing customers that they need more hardware on it, but try. Performance testing need to be, we're investing a lot of efforts into doing performance testing, and it's a very time-consuming thing. So try to get as much return on this investment as possible. It's a very good idea to have some performance tests running in the background, pointing to the same server that manual testers are, or you're doing your exploratory testing on. Manual testing are doing. And it's almost for free. You already have scripts running, yeah? You already have tools to do it. And guess what? Like when users are going to use your system, it will be under load. It won't be just 5 QA people poking on it. So it's a good idea to try to do it, and it's for free. Use it. You could also use load test script to find functional instability bugs. Again, your tests are there. You kind of doing this automatically, because if you're putting a system on a test with like under load, they're repeating the same functional operation, hopefully, that your users are going to do. So there may be bugs there that you can find this way. Yeah, definitely intermittent bugs is the best way to find them. Memory leaks, it's a killer. And everything leaks, including Java. And this is why system goes down. So if you don't monitor your system for this, you may find surprise. If you need to restart your server every day, every week, every month, something going on. Measure it, monitor CPU, monitor memory, make graphs of this. And then you need to narrow down, put a lot of efforts to eliminate these memory leaks. And guess what? They can be introduced at any time. Every time somebody changes code, you may introduce it. So it really should be a constant problem. One of the tests that I forgot to mention is a good idea just to make sure that your system can run for months without reboot under moderate load. Intermittent problem I already mentioned. And as part of your smoke test, if your infrastructure is set up, it's easy to set up, run them. Just add to your coverage. You already invested into it. Use it. So basically, I think that Agile really makes it easier to do performance testing. Well, software is stable and ready, so you can actually do testing early. Also, performance testing, as I mentioned, is an iterative process. It requires multiple cycles. So it really fits very well with Agile ideas that you're doing work in iterations. You're doing, every time you learn more and you do another test, you learn more, you change, you do and learn and so on, yeah? And also performance testing is team activity. So you need to have your entire team focus on it, have testers, developers, performance tester, network engineer, hardware engineer, your architects, your DBAs working together to solve it. Again, in Agile world, it's a norm. We're working as a team. There's no walls between us. That's kind of it. Almost in my time, so I probably have time for 1 or 2 questions, but
what's
no
the
more.
tool that can parse and analyze the logs?
I don't know. I think we wrote our own, but if you send me email, I can. I'll talk to our performance engineers. Maybe they can recommend something. Yes?
Do you ever do any performance testing in virtual environments?
We do. It's not ideal, but at the same time, some production environments are now using virtual environments. Just because it's so easy to, it's more important to be able to scale and add more capacity fast enough than actually use this overhead become negligible at that point. You can definitely use some virtual environment for performance test teams' internal use. Yes, if they need to test, create complex environments, see a fault like how failover happen and so on. You can use that environment also for them to debug their tests and so on. Yeah. I'm still here until the end of the conference, so if you have more questions, guys, please ask me. And so now we have 15-minute break, and then John will do another presentation.